A number of times in these notebooks, I've used the word import in one of my code cells. For example, in our higher or lower game, we used import random and then some code to generate a random number for that guessing game. This is the video where we're going to explain how that works. So one of the big advantages of coding in Python is that there's a very, very large community of Python programmers. Many people release their code that they've written freely for other people to use. And no matter what you want to do, the chances are that somebody's written and released a Python module which will help you do that. When people package their code into a module, you can use it with the help of the import command. Now, getting other people's code into the right place so it can be accessed with an import command can be tricky. Happily for us, CoCalc, the software that you're using to do your weekly notebooks and your assessed questions, and the Anaconda Python distribution, which is what I recommend people use if they want to install Python on their own computer, have the most popular and most useful mathematical modules automatically installed, so we're not going to have to worry about that. Let's move on to using this import command. As a demo, we're going to use import math, which gives us the Python math module. That contains mathematical functions like the sine function, cosine, other trigonometric functions, log to the base 10, log to the base e, as well as some useful mathematical constants like pi and e. If you want to see the full list of contents of the Python math module, you can do it by clicking on the link right here, which you'll be able to do if you download this notebook. So to use the contents of the math module, you put the words import math into a code cell. When you've done that, you can access functions from the math module by using math dot, then the function name. So here's an example. We're going to have import math on the first line, then on the next line, we're able to use the cosine function by typing math.cos. Math.cos of 0 should be cosine of 0, which is 1. When I run that, you can see I really do get the output 1. If you try to use math.cos without an import statement, you'll get an error because Python won't know what math.cos means. You only need to run the import math statement once. Once you've run it, you can use math functions everywhere in your notebook. So on this next code cell, there is no import math statement, because we've already executed import math, I can use this math.log function. Here I'm doing math.log of math.e, and math.log is the natural logarithm, sometimes written ln. So the answer here should be 1, and indeed it is. This isn't the only way to use the import statement. If you want to import a module with a long name and give it maybe a shorter name, you can do that by import something as something else. For example, if I'm too lazy to type math every time that I want to use a function from the math module, I could do that by using import math as m. Then instead of having to type math.cos or math.log, I can simply type m.cos or m.log. So here, when I've done import math as m, then I can access functions from the math module with m.cos. You can even import functions from a module and use them without any dots at all. The syntax for doing that is to use from math import and then the name of the functions or objects you want to import. If there's just one, you can type from math import whatever. If you want to import more than one, you can separate them with commas. In this code cell, I've got from math import atan and sin. Here, atan is arctan, the inverse tangent function, and sin is the sine function. I should mention that for Python's math module, trigonometric functions like arctan or sine or cosine are always in radians, not degrees, but radians. So if I do sine 0 plus atan, a very large number, well, sine 0 is 0, and arctan of a very large number is pretty much pi over 2. So you can see the answer is, as expected, pretty much pi over 2. You can even import absolutely every function from a module so that they can be used without the dot notation. To do that, you just do from math import star. That imports every single command from the math module and allows you to use all those commands without using math dot. So when I run this code cell, I can use functions like the Radians function, which belong to the math module without any math dot. Here we do radians 180, that converts the 180 degrees into radians, and we get the expected answer of pi. You have to be careful when doing this. The reason is that if you had a function, if you'd already defined a function with the same name as one of the functions from math, then it will be overwritten when you import it from math. The math dot whatever function might seem cumbersome, but in fact it does have the useful benefit that it avoids overwriting any functions or variables that you've already defined. So you have to be careful when using things like from math import star that you don't accidentally cover up any functions that you'd already defined. Let's now look at a different module, which is the one that we used in our higher or lower game, the random module. Random contains functions for generating pseudo-random numbers. Pseudo-random just means that they're not really random, but they're as good as random for any purposes that we're going to have. I'm going to describe a few of the most useful functions, but again, if you want to see all of the functions available in the random module, you can click on the link in this notebook. You can download these notebooks from Moodle, by the way, or you can just go to the official Python documentation and search for the random module. So in this line, I'm importing random, which will allow me to use functions from the random module. The first function we're going to look at is random.randint. Random.randint AB produces a random number between A and B inclusive. So A and B are both possible, as is any integer between A and B. As an example, random.randint15 will produce a random number which is one of 1, 2, 3, 4 or 5. Here it's 3, but if I run it again, I'll get a potentially different one. So we'll just run it a few times. You can see I get lots of different possible answers. So there is a slightly surprising thing about this syntax. You'll remember when we used things like range. Well, if I had range AB, produce the numbers A plus 1 up to B minus 1. But random.randint produces, or can produce, all numbers between the first argument and the second argument inclusive. It's a bit of an annoying inconsistency in Python, but we just have to live with that. If you want a random decimal number, then random.uniform 0, 1 will produce a random decimal between 0 and 1. Or if you want a random number between 1 and 3, random decimal number between 1 and 3, you can change it and like this, and you'll get a random number between 1 and 3. Random has functions for doing random sampling. If you want to choose 2 elements at random without replacement from a particular list, you can do it with random.sample, where the first argument to random.sample is the list that you want to choose from, and the second argument is how many elements you want to choose from that list. So when I run this, what I'll get is a list of 2 elements chosen at random. What without replacement means is that you can't get the same element twice. So if I run this a bunch of times, you will see that we never, ever, ever see the same element twice. That's what without replacement means. So you could do this with any list. If you want to choose a certain number of elements at random from a list, then random sample is the function that you're looking for. Finally, there is a way to permute a list at random. Here I've got the list 1, 2, 3. If I then do random shuffle to that list, then it will change the list. And the way it changes it is by reordering it in a random way. So if I define A to be 1, 2, 3, and then I call random.shuffle on A, then A will actually change to be a random permutation of itself. So there we happen to get the identity permutation. If I do it again, we've got the identity permutation again and again. That's quite unlikely. But then this time we got 2, 3, 1, 2, 3, 1, 1, 2, 3, 2, 1, 3. You can see that each time we run this, we get a different random permutation of the list 1, 2, 3. Finally, it's possible to write your own modules. This is not something we're going to do in 0011, but I'm just going to mention it because it's on the syllabus. If you write your Python code and save it in a file mycode.py, so you can't do this with notebooks. You have to do this just in an ordinary text editor and send it as mycode, save it as mycode.py, And if you save it somewhere the Python interpreter can find it, then using import mycode will make your functions in that file available by using mycode dot and then the function name. Again, if you want to see further details, there is a link to the official Python documentation in this notebook.